Who are you, and what did you do with the chicken? No. I do not want to see you again. All right, let's go on. We are today getting the introduction to the wonderful world of trigonometry. This is great stuff, extraordinarily useful stuff. Stuff that, by the way, your pre-calculus teachers will expect you to know. Stuff that your college teachers will expect you to know. Stuff that will get you successfully through even the first semester of engineering at University of Maryland. I know because I have been there. Trigonometry. This part referring to triangles. We're going to be studying the measurement of triangles. Well, haven't we been doing that? Not like we're going to see it today. First of all, back to our old friends here. In a 30-60 triangle, you know how to get from the short leg to the hypotenuse. You just double it. You know how to get from the short leg to the long leg. You just multiply that 1 by square root of 3. So what do we have going here? These are just ratios. The ratio of short leg to hypotenuse is 1 to 2. The ratio of the short leg to the long leg is 1 to the square root of 3. In a 45-45, the ratio of one leg to the other leg is just 1 to 1. The ratio of the hypotenuse to the leg is square root of 2 to 1. Or from leg to hypotenuse, 1 to square root of 2. These are just ratios. That's all that we've been looking at in the last couple of sections is just ratios. But what happens if you have a triangle that's not a 30-60 and it's not a 45-45? What if it's a 25-degree angle here? If that's 25, this would have to be what? 65. What do we do with a 25-65 triangle? Is there a particular ratio between, say, the side opposite? We're going to look at this angle. We're going to call this the opposite side, of course, and this will be the adjacent side, adjacent meaning right next to. So we have the opposite side and the adjacent side. Is there, for a 25-degree angle, is there a special ratio, just like there is if it were a 30-degree angle? Is there one particular ratio? Yes, there is, of course. But what is it? I don't know. I have no idea right offhand. I do not know what that ratio is. But there is one number that tells you what you would multiply this guy by to get that guy. Somebody knows what it is. In fact, there's a chart in the book on page 311 that tells you what the ratio is. Now, this is the beginning of trigonometry. We have a special name for the ratio of the opposite side to the adjacent side. The opposite side compared to the adjacent side has a name. We call that the tangent ratio. Now, by the way, if you're thinking, oh, I know what a tangent is, I studied this back in middle school. It's a line that touches a circle in just one point. True, but in the context of trigonometry, it doesn't mean that at all. In trigonometry, when we talk about tangent, we're simply talking about the ratio of the opposite side to the adjacent side. Opposite over adjacent is tangent. That is the first ratio, trigonometric ratio, that you have to know. Simply the tangent is what? Opposite over adjacent. Tangent equals opposite over adjacent. Now, by the time we're done with this, I'm going to give you a trick. I'm going to introduce you to an old friend of mine and give you a trick that makes it very easy to remember the definitions of the three trigonometric ratios we're going to be studying. Tangent is the first one. You have to know now and for years into the future, you have to know that tangent is opposite over adjacent. So far, not too hard to understand that. Let's look at a quick example. Suppose, let me start from scratch. Suppose we have some triangle, and it just happens to be a leg of 3 and a leg of 4. Yes, you know this one from several sections ago. If the legs are 3 and 4, you know what the hypotenuse has to be. Remember Pythagoras? A squared plus b squared equals c squared. 3 squared plus 4 squared equals c squared. 25 equals c squared, so c is 5. Remember the 3, 4, 5 ratio in right triangles? If legs happen to be 3 and 4, the hypotenuse has to be 5. So in this case, what is the, we need to name an angle here. Let's call this angle A. We'll call this one B. There's a long-standing tradition, by the way, in trigonometry that we like to call the right angle C. And opposite the right angle, we'd like to call this side C. Likewise, opposite point B, we like to call this one B. And opposite point A, we like to call this one lowercase a. Right now, those are not important. We're going to look at angle A. So zeroing all of our attention in on angle A, right here. Which side is opposite angle A? It's 3. Which side is adjacent to angle A? It would be the 4. So what is, here's how we write it, what is the tangent of A? The tangent of A, by definition, is opposite over adjacent. The tangent of A is opposite over adjacent. The tangent of A is 3 over 4 in this case. The tangent of A is opposite over adjacent. 3 over 4. In trigonometry, by the way, better known as 0.75. In trig, we like decimals. We like decimals very much. We don't mess with fractions in trigonometry. We deal with decimals. But if this were a test question, if I gave you this diagram and asked you for the tangent of A, and you would say to yourself, oh, tangent, that's opposite over adjacent. That's opposite over adjacent. That's 3 over 4. And if you gave me an answer of 3/4, you are perfectly right, 100%. Good. Although we prefer to say 0.75. What would be the tangent of angle B? The tangent of B is different. Because if you put your attention on angle B, which side is opposite angle B? 4. And what's adjacent to B? 3. So if tangent is opposite over adjacent, what's the tangent of B? It would be the opposite over the adjacent. It flips. We've got the reciprocals here. So the tangent of A is its opposite over its adjacent. But the tangent of B is its opposite over its adjacent. The 3 and the 4 swap roles. What used to be the adjacent turns into the opposite, and what used to be the opposite turns into the adjacent when you switch to the other angle. Pretty easy so far? I think so. What's the tangent of C? We're not going to mess with the tangent of C. We'll save that for pre-calculus. For now, let's just say this. We don't talk about the tangent of the right angle. We will some year, but not in this book. So we don't talk about the tangent of the right angle. We only deal with the tangent of the two acute angles, A and B. Now, what do we do with this? Let's look at an example of, well, first of all, let's get a little more general here. Let's get rid of all the numbers, all this stuff. All right, so suppose I ask you for the tangent of A, and let's call these sides, let's name them the way I talked about before. If that's point A, we like to call this side lowercase a, representing the length of this segment. And if that's point B, we like to label this as being lowercase b, that's the length of this segment, is the unknown b. And because that point is called C, we like to label the hypotenuse the lowercase c, representing the length of the hypotenuse that we don't know, which is just c. Then what is now the tangent of A? The tangent of A is its opposite over its adjacent. The tangent of A is A over B. And what is, let me introduce right now to you, we do not normally spell out the word. That's way too much trouble. Wow, that's what, 7 letters. That's too much work for us. We are practicing mathematical laziness. There is an abbreviation for tangent. We write that. So we say the tangent, and by the way, when you read this, do not say tan. You go into your college classroom and you talk about tan of A, they will laugh you right out of the room. We do not pronounce that tan. Kind of like when you see this. How do you pronounce that? Do you say mr? No, that's crazy. You would say Mr. How do you pronounce that? Do you say mrs? No, it's Mrs. Likewise, when you read that, do you say tan? No, that's silly. When you see that, you read tangent. So we have tangent of A. What is the tangent of A? Oops, we already did A. Let's do tangent of B. The tangent of B. Tangent is always equal to opposite over adjacent. Always. So the tangent of angle B would be its opposite over its adjacent. The tangent of B is the opposite over the adjacent. Tangent always equals opposite over adjacent. Now, what does all this do for us? It's so fantastically wonderful. Here's the deal. Let's go to the next example in the book. The book says we've got a triangle. Looks like that. It's a right triangle. By the way, all of this only works in right triangles. If you want to get into things that are not right triangles, well, wait till pre-calculus. We'll see it then. But this only works in right triangles. Suppose this side has a length of 32, and suppose this angle is 56 degrees. And suppose I'm looking for this guy. Hey, if this were a 60-degree angle, it'd be easy, right? I would take 32 and multiply by square root of 3. But it's not 60. Sorry, it's not quite that easy. There are a few of these trigonometric ratios that we have memorized. You know how to deal with 60-degree angles and 30-degree angles and 45-degree angles. We have those ratios memorized. But we don't have, what was it again? 56. We don't have the ratios for 56 memorized. You would be crazy to try to, well, not crazy. You would be a real math nerd if you tried to memorize the ratios for a 56-degree angle. I don't know of anybody who would do that because there's a better way. So here's the deal. We put all of our attention on that 56-degree angle. We say, in relation to that 56-degree angle, what is this guy called and what is that guy called? This guy is called its opposite. I'm going to abbreviate OPP. That doesn't look like a P. And we're going to abbreviate the adjacent as ADJ. This makes it a little bit easier because we hate long words. So for the 56-degree angle, there's the opposite, There's the adjacent. So here's what we write. We write tangent of the angle, tangent of 56 equals what? Tangent equals opposite, which is y, over adjacent, which is 32. Pretty easy so far, right? Tangent equals opposite over adjacent. Tangent of this angle, tangent of 56, equals opposite over adjacent. Now, next step. We go to page 311. On page 311, there is, see if I can get a little closer here so you can see what it looks like. On page 311, I don't know how well that's working for you, but on page 311, so you need to open your book and look at page 311, we have a table of trigonometric ratios. A whole bunch of them. You can see why we don't memorize them, because there are a gazillion of them, and every one of them has an infinite number of decimal places. This book only gives us 4 decimal places for each one. No one's going to memorize this. But if I go to the tangent column, you will see here in the book that we have, if I can point here, I don't know, we have a column called sine, we have a column called cosine, we have not gotten to those yet, and then we have a column called tangent. And those same 3 words are repeated on the other side. We're focusing today on the column called tangent, right there, the tangent column. In the blue column over here, we have angle measures. Aha! So I want to find the tangent of 56. That gives me the ratio. So I go to the tangent column, right? Maybe I can do it this way. Oh, yes, here we go. This will work. See, I even see what it looks like from your point of view in my viewfinder. Yes. I go to the tangent column right here, and I'm going to come down until I hit the row for 56 degrees. I come down here and I get frustrated because it ends at 45. Where do I go from there? We go to the next column over on this side, and I come down to 56 degrees. Sorry, my book is bebopping around so much. I find 56 degrees right there above my finger. Then I go across until I'm in the tangent column, and right there I see it. I see that the tangent of 56 is 1.4826. So I go to the board. I now know what that equals. It equals 1.4826. By the way, it doesn't actually equal 1.4826. It's about equal to, because this in reality is an irrational number that goes on forever. Our book chose to show us 4 decimal places. But it's actually not exact. These are irrational numbers. Another reason we don't memorize them, because they're irrational. So the tangent of 56, we look it up in the book, we change it to 1.4826. It's still equal to, oh, I got things so crowded here, I can't work. Let's pull this down out of the way. Oops, left behind my 1. That's important. Gotta have that guy. Oops, got that extra circle there. Oh, so much trouble here. Let's get rid of this silly circle. Okay. So, I have looked up the tangent of 56. I got 1.4826. I bring down my y over 32. How do I now solve for y? Yeah, pretty easy, isn't it? All you do is multiply both sides. By the way, this is very basic algebra. Please do not tell me you don't know how to do this. Just keep it a secret and watch the quick review. How do we get rid of division by 32? We multiply both sides of the equation by 32. Of course, those cancel. So we end up with y equals 32 times 1.4826. And what is 32 times? Well, I'm going to cheat and just look at the book because they gave us this example. 32 times 1 point, whatever, 84826. The book says, I'm on the wrong page, there it is. It says we get about, we end up with y. Oh, this wiggly equal sign, by the way, means approximately equal to. I've also seen it done in some books like this with a dot over the equal sign. That also means approximately equal to. I like the wavy equal sign because, you know, kind of approximately equal to, approximately. It's about equal to 47.4432. 47.4432, I think is what I said. But the book will usually, and on the test, you'll usually be asked to round it to the nearest tenth. To the nearest tenth, that's the tenths place, we would just call it about 47.4. So if we have a 56-degree angle, and this leg is 32, then the opposite side will be about 47.4. It's not a bad process, is it? No, it's not. Let's see. We need to see at least one more example and then show you one more thing. Let's just make one up. Cool thing about this is once you understand that tangent equals opposite over adjacent and you understand what that means and how to use it, you can't invent a hard problem. They're all done the same way. That's why the scores on the Chapter 8 test historically have been very high, because once you learn the tricks, I don't know how to make a hard problem. We make up anything we want. Here's a right triangle. Suppose this is 20 degrees. I don't know, just make up something here. And suppose this is x. And suppose this is, I'll make a real easy number to work with. I like tens. Tens are easy to work with. All right. I don't know, I don't have memorized the ratios for a 20-80 triangle. Oops, I'm sorry, a 20-70 triangle. We have 30-60s memorized. We don't need trigonometry for those. We have 45-45s memorized. We don't need trigonometry for those. We know those ratios. But we don't know how to do a 20-70. So we lean on page 311. And we lean on tangent. So I write what? I write tangent of my angle is what? Tangent always equals opposite over adjacent. The opposite side is unknown. It is x. The adjacent, right here next to the angle, is the 10. By the way, why don't we call this the adjacent? Oh, that has a special name. We don't call that the adjacent. We call this, of course, the hypotenuse. This is always the hypotenuse. We never call it the adjacent in trigonometry. The adjacent is the guy next to the angle that's not the hypotenuse. Okay? All right, so we have x over 10. Now what do? We go to page 311. Or there's another trick you can use. You can grab what I'm about to grab here. I happen to have in my hand here a calculator that stopped working, but you can grab your, hopefully, working calculator. And all you have to do is put in, now this particular calculator, when it's it's working. A miracle, okay. I believe with this one, what I do is, some calculators you put in the tangent key first and then the angle. Some calculators you put in the angle first and then the tangent key. This calculator, I think we put in the tangent key first. Now, right there, TAN, one of those buttons on the one of those buttons on the calculator that you never knew what it was for? Well, now you do. You hit the tangent of 20, and that tells me I get that nasty number. And then I multiply that by 10, and I get my final result of 3.639702,343, but we round that to about 3.6. Now, there's one little glitch possible here. That one little glitch is your calculator comes from the factory preset for something different than degrees. There are a couple of ways to measure angles. We've been using degrees. We will continue using degrees. When you get to pre-calculus, you'll start using something else called radians. Your calculator may already be set to use radians. So if you put into your calculator the tangent of 20 degrees, and you get something other than 0.3640, then your calculator is probably set for radians, and you need to change it to degrees. We're not going to go over that procedure right now, though. Why not? Because you've got page 311. You don't really need the calculator. You've got page 311. Use page 311. It's faster than a calculator, really. So, once again, how do we handle this? The tangent of 20 is x over 10, because tangent of 20 is opposite over adjacent. X over 10, there it is. You look up tangent of 20, and as many times as I've seen it, you think I'd remember it. But I look up the 20-degree angle. I go over until I'm in the tangent column. Try it for yourself in your book, page 311. You should be able to find 0.3640. So you change that to 0.3640 equals x over 10. How do you solve for x now? You just multiply by 10 on both sides. So that means x is, how do you multiply a decimal by 10? Just move the decimal point one place to the right. We get 3.640. But if the instructions say to round it to one decimal place, we would change it to just 3.6. All these are approximate. If you use an equal sign instead of an approximate sign, that's all right. I'm not going to penalize you. So x is 3.6. Now, two additional little glitches in the system here. What if I give you, say, 35 degrees, and I tell you that this is 10 and this is x? All right, same thing. You know how to do this now. Tangent of 35 equals its opposite over the adjacent. Its opposite over the adjacent. We look up tangent of 35. I go to my book and I see that the tangent of 35 is 0.7002. 0.7002. I'm changing that into that. So 0.7002 is still equal to 10 over x. Now the question becomes, how do you solve for that? If you've got 0.7002 equals 10 over x. By the way, don't round that off until you are finished. Then you can round it to one decimal place. If you round it too early, that really messes things up. So how do you solve this? Well, one way to do it is, let's multiply both sides by x first. Multiply both sides by x first. These cancel, and now I have 0.702 times x. But now how do I get rid of that 0.702 to get x by itself? I'll then divide by 0.7002. Divide by 0.7002. Basic algebra here. These cancel, and I find out that x is 10 divided by 0.7002. Pull out the calculator and figure out 10 divided by 0.7002 and round your answer to the one decimal place and you're done. No, it's not going to be 7.002. 10 divided by 0.7002 is going to be something else entirely. Use the calculator. There is an easier way though. Suppose you say, oh, Mr. That's such a pain. I'm not going to remember how to do that when the x is in the denominator. I'd rather have the x in the numerator. Yeah, so would I. Hey, how about if we try this trick? If that's 35, what's this? Don't these angles have to add up to 90? And looking at that number and thinking about a number I used earlier, it might have been on the, earlier today. I might have said something silly earlier. But if that's 35, this has to be 55. If I said 65 earlier, I was dreaming. If that's 35, that has to be 55. So if you don't like having the opposite over adjacent, if you don't like having the x in the denominator,